Have you ever had a project that got so successful, it actually started to break? You know the feeling. You're adding features, your users are loving it, but behind the scenes, your code is turning into a tangled, unmanageable mess. Well, that's exactly what we're diving into today, the strategy design pattern. It's a brilliantly simple way to solve that exact problem and keep your code clean and scalable.
So here's the game plan. First, we're going to tell a little story about an app that became a victim of its own success, something you have probably seen before. Then we'll introduce the hero of our story, the strategy pattern. We'll pop the hood and see exactly how it works, connect it to a super simple real-world example, and then, most importantly, we'll talk about why and when you should pull this amazing tool out of your toolbox.
All right, let's kick things off with Section 1 and a story I call A Victim of Its Success.
So let me ask you this. What if your biggest success was also your biggest headache? Imagine you built this awesome navigation app. It's a smash hit, everybody loves it, and the feature requests start flooding in. Now, this sounds like a dream come true, right? But in reality, it's often the start of a massive technical nightmare. In the beginning, life was good. The app did one thing, and it did it really, really well. It found the best driving route from point A to point B. The code was clean, it was simple, users were happy. Just a perfect start.
But you know how it goes. Success brings new demands. Suddenly, users want walking directions. Then, they want public transportation routes. Then, hey, what about routes for my bike? Can you show me the most scenic route for tourists? And each time, a new algorithm just gets crammed right into the main code.
And this is where things start to get, well, ugly. The main class just gets bigger and bigger and more complicated. It's a monolith. And now, when you try to fix a tiny bug in the cycling algorithm, it somehow breaks the car routing. It's a developer's nightmare. For your team, this means endless merge conflicts and just a whole lot of frustration. The very success of the app is making it impossible to work on.
Okay, so we've just painted a pretty bleak picture, and it's a really common one. But don't worry, there is an elegant solution. This is that aha moment where the strategy pattern comes in to save the day.
So what is this thing really? Here's the textbook definition. The strategy pattern lets you define a family of algorithms, think of our different routing methods, and then you put each one into its very own separate class. The magic is that you can then make them totally interchangeable. They're like different attachments for a power tool that you can just swap out whenever you need to. The big idea, the secret sauce here, is all about separating the what from the how. Our main app, the Navigator, still knows what it needs to do, plan a route, but it completely delegates how that route gets planned. It just hands the job off to a strategy object. Is it the car strategy? The walking strategy? The main app doesn't know, and it doesn't care.
Okay, that all sounds great in theory, but what does this actually look like in the code? Let's deconstruct it and get under the hood.
There are really just four main players in this pattern. First, you have the context. That's our main navigator class, the one that got all bloated. Then you have the strategy interface. Think of this like a contract that says, hey, any routing algorithm we create must have a method called, say, build route. Third, we have the concrete strategies. These are the actual classes that do the work. A road strategy class, a walk strategy class, and so on. And finally, there's the client, which is just the part of your app that decides which strategy to use at any given time.
And this right here is where the magic happens. Our navigator, the context, just holds a reference to one of these strategy objects. When it needs a route, it doesn't check which one it is. It just says, hey, whatever you are, run your build route method. It could be talking to the road strategy or the bicycle strategy. It has no idea. This is what we call decoupling, and it's what makes this whole system so incredibly flexible.
So what if you want to try this yourself? It's really just a 5-step recipe. First, find that algorithm in your main class that's always changing and causing problems. Second, create a common interface for all the different ways you do that thing. 3, pull each of those variations out into its own separate concrete strategy class. 4, back in your main class, just add a field to hold whatever the current strategy is. And 5, you just let the client code pick and pass in the strategy it wants to use.
You know, sometimes the best way to understand a programming concept is to forget about code for a second. So let's look at a simple real-world analogy that really makes this whole idea just click.
This is honestly the perfect way to think about it. Your goal, the what, is simple. Get to the airport. The how is your strategy. You could take a bus, you could order a cab, or you could even ride your bike. Each of those is a different strategy to achieve the exact same goal. And you can choose your strategy based on your needs right now.
Maybe you want the cheapest option, or the fastest, or maybe you just feel like getting some exercise. The goal never changes, just the strategy.
So now that we get the pattern, the really big question is, when should you actually use it? I mean, it's a powerful tool, but it's definitely not a silver bullet for every problem. Let's look at the payoff and the ideal scenarios.
These are the classic signs, the big red flags that you should be reaching for the strategy pattern. If you have one task with a whole bunch of different ways to do it, that's a huge tell. It's especially powerful when you need to switch between those methods while the program is running. And oh man, if you find yourself writing a giant if-else chain or a massive switch statement, that's your code screaming at you to use this pattern.
Now, like any pattern, there are trade-offs. The pros are huge. You can swap algorithms on the fly, and your architecture gets so much cleaner. But for a really simple problem with just 2 algorithms that never change, yeah, it might be overkill. It does add a few more classes to your project, and the client code has to be aware of the different strategies available to choose from.
And this brings us to one of the biggest wins and a core principle of good software design, the open/closed principle. It basically says your code should be open for extension, but closed for modification. With our strategy pattern, we can add a brand new scooter strategy or even a futuristic Hyperloop strategy just by creating a new class. We never ever have to go back and change a single line of code in our original Navigator class. That is incredibly powerful.
And just a quick note, you might be thinking, hey, this sounds kind of like the state pattern, and you're not wrong. They look similar. But the key difference is the intent. The strategy pattern is all about having different ways to do the same thing and letting the client choose which one to use. The state pattern, on the other hand, is usually about an object changing its own behavior based on its own internal state.
So, as we wrap this up, I want to leave you with a question to take back to your own work. Take a look at your code base. Where are different hows all hiding inside the same what? Find those spots, and you've just found the perfect opportunity to use the strategy pattern and turn a complex mess into clean, beautiful, and manageable code.